Yes, thanks for making your time here. So I'm Hwee from DataRobot. Today I'll be presenting a little on DataRobot, of course, and to show you guys how are you going to build a machine learning problem and also to address it within the next 30 minutes. Alright, so we will first start off with, since today the agenda is the Augmented Analytics. Within DataRobot, we have also written down like what do we think the analytics is. So we have actually split them up into 3 different sections. So it will be like the data preparations, data discovery, and of course the data science aspects as well. So all those, I will not go into too much into details because they are all on the web. And I'm sure you guys, if you are interested, we can send you the link and you can read up when you are free. Alright? Okay, so let's move to our presentation. Yes. Just give us a minute. Okay, so yes, so today what we're going to show you is, of course I'll be doing a demo later on, but I'm thinking before I start on the demo, it's probably good to give everyone an idea, a background of what I'm going to talk about or even to demo as well. So as what we have mentioned earlier, today the demo is on using DataRobot, of course, to do the default risk modeling. Right. And of course, what is the business problem that we're trying to solve here? We have also mentioned that earlier that you see everyone has got a different risk because, for example, in a bank, when you want to take up a loan, so imagine yourself in the shoe of the bank. When someone comes and wants to take a loan, are you going to just approve every single one? Or are you going to think of how risky the person is? And of course, if the person is risky, how much are you willing to lend them? And of course, at what interest rate and stuff. So those are the things that we want to address. Okay, so of course, every machine learning problem starts with the data. If there's no data, there's actually nothing much the machine can learn from. So today, the type of data that we will be using will be like, for example, the demographics data, including the incomes and everything, and of course the loan data as well. So for example, the interest rate, what is the rate that you're using for the loan today? Okay? Yep. And also, like I was saying, within DataRobot, it's a machine learning problem. So the machine will learn by itself. What is the patterns? Find the correlation by itself. Because I'm sure in the crowd here, who can code in R? Who codes in R? How about Python? How about some other languages? I don't see a lot of hands actually, but don't worry because to do this, to use this, you can use code, but there are also other options as well. Alright? Okay, so within DataRobot, I'm sure we can do a lot of different algorithms out. And I guess the earlier speaker, we were also talking, there was a question earlier, why do you choose a particular model and not some other ones? So yes, that is a very common question actually, because why this algorithm, why not that, why not this, why not that? So in order to address that, there are of course a lot of different ways. One is to test everything out. But of course, if you want to test everything out, it's going to be very time consuming. And how much time do we have on hand? Everyone, there's only 24 hours a day. Yes, so what we want is to get it quickly done. And I can show you in a while, like within that 30 minutes or so, given a reasonable internet connection, I got to say that first, I will be able to generate close to about 70 models about that. Yeah. And also, other than the models, so for example, for every risk, for every customer, right, like earlier we were saying, every customer who walks in, we want to know how much or how risky the person is. So this will be an example of the output. So every customer, every applicant comes in, we will give a results of how probability, how risky the person is, applicant is. And then the business can take decision on whether do you want to approve the loan or not? Okay, and also together with, other than to tell you the scores, a lot of business users, they always come back and say, okay, now you're giving me the scores. So how do you derive to the score? Can you explain to me what's behind it? How do you do this? What are the features you use? What is important? Why do you say this and that? Yeah, there's a lot of why. So from some of the charts that I will show you in a while, is out of all the different features, we will tell you what are those features which are the most important in the prediction, and of course, and how are they important as well. Okay, so from all this chart, and then we have, if you have some textual data, because earlier there was a talk on the sentiment analysis where we use a lot of text as well, right? So yeah, I know you guys collected a lot. So how do we make use of it? Because I know it is a lot of hard work doing NLP. I tried that before, and I told myself probably I should not try that again for myself because it really takes a lot of hard work. So with the software that we have, it's actually quite easy for us to do. And also, since we are giving the results, right, we are giving the probability of how risky the individual is. We also want to explain why, because earlier the few slides that we've shown are actually on a whole, the model as a whole. How do we, or rather what are the features we use and how each of the features impact the model as a whole. But to the individual ones, because like we say, not everyone is the same. So I can be given a very high score while everyone else is given a very low score. But the reason of me getting a particular score can be different from one another. So these are the things that we want to identify out as well. Alright? So now maybe we can move on to a demo where you guys can have a first-hand look on what DataRobot is about. So yes, landing page, like what we have seen everyone. So we can digest a lot of different files. So I know a lot of data is in like SQL Server, there's connection directly into it. But of course, if you don't want to touch your database, if you have a flat file in your machine, you can also load it up into this DataRobot platform for you to do the machine learning. Okay. So what we do is we are loading the data up right now. So the data that I'm loading is called Landing Club. So my demo right now is running on the cloud. But we have got a lot of different options because of data privacy, I'm aware of that. So, but for the demo today, we are just using the cloud. And it takes a little time because it is actually sending the data up to the US cloud. It's at the other side of the world, so it's crawling over still. Okay, so while the data is being loaded, we actually have prepared another tab, which is where the data has already been loaded up. Yes, so after it's done, you'll see a screen like this. So what's interesting is other than this white screen, right? If we scroll down a little, we will be able to see the EDA. We will be able to see what is the min, max, standard deviation of all the features that we included in. So you see like all the features that we talked about earlier, the income, the age and everything, it is all up there. And what's more interesting is if you want to know what's the distribution, because I know sometimes we give you a table like this, and you see a lot of numbers, and people like to see pretty stuff. This is where you can see the histogram pretty enough for us to know how the trend is like. Okay, so for us, what we need to tell the DataRobot is what is the thing that we want to predict. So like I was saying, in this case, DataRobot, we learn from historical data set. So which means that we have a column indicating whether the loan is a bad loan or not. So we can tell DataRobot that is the target we want to predict. So when we set that as the target, and then if we go all the way up, we can see the distribution chart plotted out as well. And it is smart enough to tell us that this is a classification problem. Okay? So other than this, we have done no codings at the moment yet. And the next thing is the most important one, which is if you see the middle, that start button, that is the most important because when we click the start button, it is actually asking the machine to learn all the different algorithms we have within DataRobot and to build the best model out of it. So within DataRobot, we have a lot of different algorithms. like a few hundreds of it. And what we do is we will test probably about 30 to 40 algorithms at a go. And of course, we will use different proportion or different population of data to do the testing. So for the very first round, we will use like 16% of the data. And then like assuming DataRobot has selected 40 models. So 40 models will undergo that 16% of data. And then if you want to, it's like the survival of fittest. The better performing half, like 20 models, 40, half, 20 models will go into the next step, doubling the data size to 32%. And then it repeats again to 64% with the top 10 models. That is how we try to compete and compare to ensure that our models is of the highest accuracy. Okay. So if we go into the leaderboard, yes, this is where after the models has been completed, it will go out to the ranking system. It's just like the competition, the most accurate models will be up at the top. And how do we define what is accurate or how is accurate? Because everybody has got different definition, right? Some people may be using log loss, others might be using AUC and stuff. But all those, don't worry, we have a function there, the metrics, where we can select the best or the most comfortable metrics that we are with. Okay, so in this case, okay, maybe I choose the AUC for example. So if you realize, when we switch the metrics, when we change the metrics to something else, the leaderboard will change automatically as well. Because the most accurate one will always be at the top. It will just reorganize by itself. Okay, good. So this is the leaderboard. Very nice so far. So we have like, well, I can't read how many models do we have. Okay, we have a lot of models, 20 runs so far. So if we want to understand what the models does exactly, we can click into the leaderboard and then it will show us the blueprint. Yes, a blueprint. So we can see over here, okay, for all the different data, all the different variables that we have input in, it will understand by itself whether it's a text, a category, or a numeric. And then it will do its own pre-processing. So for example, if there's a missing age, someone didn't fill it in. So within DataRobot, we will fill in the missing value using different approach. So it can be using mean or median or different ways before we finally load it into the algorithm. The final algorithm, in this case, the XGBoost. So for us, other than to compare the different algorithms, right, we also compare the pre-processing as well. Because sometimes different way of processing the data will give us a better accuracy, which we wouldn't know until we try it out. So other than to tell you what has been done so far, oh, it's very good that I know what has been done to my text, what has been done to my numeric and everything. So next, if you recall earlier, I showed you some bar charts. That is what we call the feature impact. So from the feature impact, this is what it tells us. What is the most important features that the model takes in? So in this case, we can see that the description is the most important, followed by the annual income. So description is very important. And okay, probably I didn't really highlight earlier. Description is a free text field where the applicants can just go in and type why are they borrowing the loan for. So within DataRobot, I can bring you to a word cloud where it will show you the different wordings. How impactful are those wordings? So in this case, the font size represents the frequency of the word. So you can see that, okay, because this is a loan data set, so definitely everyone is trying to take a loan. Alright, that's why the loan is of a biggest font. And the color in this case is the probability. Red color represents higher probability. The blue is the lower probability. So if you see over here, you see if people are using it to do some payments, paying some bills is of a higher risk as opposed to those who are doing some maybe credit card consolidation. So we can, from the work log, we can actually understand how the different reasons or why people are borrowing the loans for has an impact on their risk. Okay. So earlier we were saying description is the most important one. How about the second most important, which is the income? So for the income, if we want to drill down into the income, we can have a look at the feature effects, and there's a chart that tells us, okay, in this case, for the income, assuming everything else equal, right, how will someone changing the income affect their score? But of course, we know that, okay, people who has got maybe 10.6, okay, that's a log scale here, 10.6 log scale of their income, it is actually of a higher risk. And then if there's between like 10.6 to maybe 11.1, that is of a medium risk, and that can always be related back to the risk score on the y-axis. So over here in this chart, we can see that I know a lot of people, sometimes they use like logistic regression, where we will give you a coefficient, right? But if we really want to force in the coefficients, it is sort of like forcing income in this case to be a straight line down, a vertical line down. But if you realize, this is actually quite a step. It is not a very vertical line. So sometimes we just have to note that in machine learning, we can't really give out a coefficient unless we want to bucket them up into the different salary range, for example, in this case. But of course, if we always want to, this is what we call a partial dependence plot. If we want to know what is the actual and the prediction, there's always other functions where we can toggle on the actual and also the predictions to know how close our prediction is with the actual. So for all these different features, right, whether it's numeric or categorical, you can see it on the left. We can always jump into each of the features and to understand it and to analyze it. Yes. So other than to know what is important from the feature impact and how is it important from this feature effects chart and the work log, next is we were saying we want to do a scoring on each of the individual. Correct. So for DataRobot, when we do a scoring for each of the individual, this is a similar chart of what you've seen from the screenshots earlier. So we look at this ID 6257. It has a probability of 75%. And of course, we will tell you what is the risk because the loan term is 60 months, is quite a long loan term. And then because they are borrowing it to do a small business, and probably historical data shows that if you want to do a small business, your risk is actually higher than if you want to use it for some other purpose. And of course, on the other end, if you look at, for example, ID 9576, it is of a very, very low chance, low probability of being a risk borrower. And the reasons is also, of course, as what it states here. So what's interesting here is other than to tell you what is the reason why the person is being given a particular score, if you look at the first feature, first reason for example, you realize they are actually all different. Because I know sometimes business they like to do, for example, do clustering for their marketing, right? If you do really a clustering, I wouldn't say that is not a good approach, but we are trying to force every single one within the same cluster to have the same characteristics. But of course, I'm sure everybody knows that even people in the same cluster, like in the same room here, we are all different in some way. So this is how we try to differentiate every single one, because everyone has their own reasons, everyone has their own purpose of being here today. So far I've talked a lot about DataRobot, the usage, the interface and everything. And I've talked about how we can load in the data, how we can build the project, and how we can understand the model, the insights and everything. So the next question will be, I guess, okay, so now that I have a model out, how am I going to use it? Correct, because if we just build a model, we put it by the side, not going to deploy it, it doesn't really make any business impact in that case. So how to use it? We have a few different methods. So one of the methods is we use a batch prediction. That is, if you have a flat file in your maybe your local drive or in your SQL server, you can just import the data in, compute prediction, and download. But this is still quite a manual process because you need someone to be sitting in front of the machine to do all the clicks and everything, right? So how do we automate this stuff? Since DataRobot, we always like to say we are an automated machine learning platform. So automated, we need to automate this prediction scoring as well. So that is, I got to draw back to the second speaker earlier. He was talking about the REST API. Yes, because within DataRobot, we have the REST API as well. Okay, so over here, let me just point you. So if we deploy the model, we will be able to show you an example of a Python script of the API, of our REST API. So probably give it a little while. In order to use this API, of course, earlier we also talked about some credentials. There's a lot of free APIs out there, which is very good for us. But I got to say the DataRobot API, you need to have the access code, which is your user ID, your password, in order to use it. So if I have to click into the first one, for example, and then if I go into the integrations, I will be able to get an example of the Python code. So most of the people that I talk to, they like this, because what they have to do is just to copy the API code, and then whenever they want to do some scoring, they just run their new files through this API, and boom, they get their scoring. And then of course, there are other options. So for example, if you are on Hadoop, there's also options where we can deploy it in Hadoop. And there's one interesting thing which I want to talk about as well, which is, you know, we have a model, we know how to build model, we know how to deploy the model, but how often do we want to refresh the model? Has anyone here tried to deploy and refresh a model before? Or update a model? Because it is quite a pain to really track the model performance. It can be whether every day, every week, every month, you've got to go in and see, okay, is my model doing good? If it's good, good, well done, I'll move on to something else. If it is not, okay, I need to rebuild my model and I have to redeploy my model again, which is I have to go through the whole cycle again. But the process of tracking, if you say if you only have one model, fine. You can manually track it. But what if you have like 10 models already in deployment? Are you going to track one by one by one by one? I guess by the time you reach the 10th model, it's time for you to go back to the first model. And you don't have any other time to do other things, right? You just have to track your model from 1 to 10, 1 to 10, 1 to 10, day in, day out. But within DataRobot, we have a dashboard. If I go into deployment, I will be able to see the whole long list of models that I have already deployed. Just give it a few seconds and it will pop up, yes. So for example, these are all the things that I have deployed. And if you realize, right, there are some like green ticks here and there, green ticks is good in my case because it means that my models are running good, perfectly fine. But there are some cases where I will see some yellow or even red color boxes or icons there. So if I see those yellow or red, it is time for me to really go in and look at, investigate what's the error. Is there any data drift or what is causing some scoring error or what? And that is where it needs my attention. So instead of me checking the model 1, 2, 3 all the way to 10, what I need to do is to just every morning look at this dashboard. Okay, everything is fine, move on, I will do some other stuff. So in that case, I will make full use of my time to do, maybe to try out more models, to build more projects, to play around a little more with DataRobot hopefully, or any other tools that you have. So after showing everything on DataRobot, right, you have seen there is no coding done so far. It's all click here, click there, drag and drop the files, right? But I'm sure if you guys want to do some codings, right? Because like for myself, I used to code in R. And then when I moved on to DataRobot, I was like, oh yes, I can just click and drag and I can get my models out as well. And even more models than what I used to do. But after some times, I'll be like, okay, maybe I need to do some codings again before it gets rusty. So for Rust, whatever that you have seen today, the click, drag, drop and everything, I would say 95 or 99% of those can also be coded in R and Python API. So if you actually go into your browser, you Google just DataRobot CranR, for example, you will be able to see the package and all the different functions in it. So yes, that is what sometimes when I feel like doing some codings again, I can go back to my R. And when there are times where I think I need a break from my codes, there's always a GUI here for me to play around with. Alright. So we have walked through how we have done, look at the data, understand the data, build the models, understand the model deployment, and up to the managing of our models. So that is sort of like a complete cycle. And all this can actually be automated like what we have seen. And I would say, everyone here, how many of you are hardcore data scientists? How many have already built some models before? Well, what about the rest? Are you planning to build models anytime soon? So I'm not too sure what is stopping people, maybe the larger crowd from doing your own, maybe try and error of building the models. But like you see over today, building a model is actually very easy. So if you have not built a model yet, try it. It's gonna be interesting and exciting. If you meet any bugs, don't worry. That is the most exciting, I would say, because debugging is the most satisfying throughout my coding experience. Yes.